On the Siglent, once you've selected the trigger menu, you can then pick the type of trigger. You do that by pressing the type button, and then you scroll through the various trigger types: edge, slope, pulse, video, window. And you may notice over here on the right, it shows what is actually going to happen. So for example, as you go through these, of course there is the edge trigger, and one of the differences here is that with the edge you get either rising, falling, or both. That is, a rising and a falling. I'm going to trigger on the rising edge. You may notice here the slope is rising. Hold off right now is closed. Hold off is a way to synchronize where you have a signal that reaches the end of this sweep, and you don't want to immediately trigger on the next one. You want to wait some period of time, and what it does is it holds the trigger circuit in a disabled state for a period of time after the end of this trigger, and that's called trigger hold off. I won't go into it in any detail. There are lots of good videos, including one on the Siglent site and one on the Rigol site, about how you use trigger hold off. I think Dave Jones with the EEV blog has talked about that, and so on. One thing I will mention is the coupling. A lot of people confuse the trigger coupling with the channel coupling. The channel coupling is whether the signal comes in with a DC level or whether it is AC coupled, in which case it's just a capacitor that blocks the DC component. So basically the waveform moves around the average value of the waveform instead of an absolute DC value. But those are not the same as the trigger coupling. Trigger coupling can be DC, it can be AC. You can also do a low frequency reject and a high frequency reject. And the reason you might need those is if you have a noisy signal, you might turn on high frequency reject. On the other hand, if you're looking for the extremely quick signals, then you probably would use low frequency reject. Okay, now let's look at each individual type of trigger. With an edge trigger, the scope is going to trigger on a transition, that is an edge in the time domain. You need to select the source, channel 1 or channel 2. Obviously, if you select channel 2 and you're only using channel 1, you won't get any synchronization. There also is an external trigger which is present on the front panel in the Siglent. I think the external trigger on the Rigol is in the back. You also can use an external trigger divided by 5. So for example, if you have a fairly high voltage signal, and by high voltage I don't mean thousands of volts, I mean a signal, for example, that's like 20 volts or something like that, you can divide it by 5 and bring it in through the external by using this position. And then finally, you can trigger on the AC line. I won't talk about that. That used to be much more useful when a lot of equipment was operated using its synchronization off of the AC line. There's not as much of that anymore. It still is useful, though, when you're looking for things like hum or AC leakage and so on. So let's go to edge trigger. In this case, you have a rising edge. You can also select a falling edge, or you can select either. And notice that when you select either, it jumps around. I'm going to go back to rising edge. The coupling is DC, and notice on the far right the noise reject. You can turn that on or off. If you turn it on, it will eliminate some of the very high frequency components from the signal. Now this, notice once again, is different from, for example, the bandwidth limit in the input channel. If you turn on the bandwidth limit of the input channel, you also will limit the high frequency response, but there you won't just eliminate it from the trigger, you'll also eliminate it from the display. Now let's look at the slope trigger. What the slope is doing is it's allowing you to set a time window and look at the slew rate of the signal through that time window. So if you think of it this way, it's saying you can set a lower level and an upper level, and to trigger, the signal has to pass between the lower level and the upper level in some particular time frame. So once again, you have to set the source, you have to set the slope, then a limit range. In this case, my limit range is within the time window that I have set. I'll talk about that in a second. You can also have it be outside the time window. Obviously, for this signal, outside the time window isn't going to synchronize because there are no pulses outside the time window. Here is the less than the time window, and notice that in this case there no longer is a real window, it's just a value, in this case 10 nanoseconds. You can have a greater than, and in this case I have it set to 2 nanoseconds. When you go to one of these greater than, less than, you may notice that the lower value is the 2 nanoseconds, the greater value is the 10 nanoseconds. The next page allows you to set the lower and upper values. It also allows you to change the coupling now and turn the noise reject on and off. And one of the things that you might be interested in is, why would you want to look at a slope rather than just an edge? The reason is some circuits are sensitive to the slope. For example, some logic gates, if the slope is a little bit too slow, they will actually oscillate on the output during the time that the signal is transitioning from what is essentially the 0 level to the 1 level. One of the reasons that Schmitt triggers are often used is they are not as sensitive. They basically latch when it goes above a certain level and switch quickly. But if you take an ordinary logic gate and you slow down its input, you'll find that particularly the high-speed gates will start to oscillate somewhere in this middle range. So you might want to look at the slope to determine, is there a signal in my system that is moving too slowly to be used in a logic gate, and if so, I might need to put it through a Schmitt trigger or some other kind of circuit that has a little more hysteresis, or in other words, does not oscillate in the center.